Greetings. Thank you for checking out this short course presentation. We assume you are a problem solver, and that's why you are here, to seek a solution. EMC squared system products are a less costly and a more widely effective alternative to the use of cement and/or lime chemicals for soil stabilization applications, especially for soils where such calcium-based elements are unsuitable or even detrimental. The EMC squared system stabilizer products were introduced to the national market more than 30 years ago, so they have a long history of testing and successful projects. Unlike the addition of cement to stabilize soils, which is primarily focused on creating a stiff, high-strength layer, unlike the application of massive doses of lime in an attempt to chemically change clay soils into entirely different materials, our goal was to provide a stabilizer treatment that would instead essentially waterproof the soil material, with increased strength being an additional benefit. It just happens that keeping water out is also the most direct and economical path to creating a stable subgrade or base course. EMC squared stabilizer products are easy to use. They are applied according to construction handbook guidelines and construction specifications that we are happy to develop for the project requirements. Application is basically a matter of following a recipe, much like making a batch of pancakes. You have 3 ingredients to work with: the native soil, the EMC squared concentrated liquid additive, and the dilution water required to make up the stabilizer solution. The gallons, or liters, of product required are calculated according to a standard application rate per cubic volume of material being treated, so you know the amount of your ingredients. Then it's just a matter of getting the water content of the treated soil mixture properly adjusted and ready for compaction, which, once again, is like making up a batch of pancake mix. Unlike the use of asphalt, cement, and lime products, where every different type of application requires that a different additive rate of the product be determined by a materials engineer for each aggregate or soil materials that is to be treated, the EMC squared projects in this presentation were all treated at the same standard application rate of the concentrated stabilizer. Now that you know how simple EMC squared stabilizer products are to work with, let's see how well they work to solve so many kinds of earthwork challenges. What is the EMC squared system? This is concentrated liquid stabilizer product technology formulated to make a wide range of soil and aggregate materials stronger and moisture resistant. A list of the product's features is shown here. They are environmentally friendly and safe to handle, non-toxic, non-hazardous, non-corrosive, non-reactive, neutral pH, and they're available in drum and bulk containers. Let's take a quick look at 4 basic different methods of applying the EMC squared system treatments. All application methods start with diluting the concentrated EMC squared liquid stabilizer product in the tank of some version of water truck or stationary storage tank. The first and most common method of application is using a water truck to apply the stabilizer solution and using either a tractor-drawn disc for mixing or a motor grader for blade mixing. Here is an item of note that makes EMC squared stabilizer different from any other form of chemical soil stabilization. Disc mixing and blade mixing are the construction operations where the strong cohesive bonding forces that are unique to the EMC squared stabilization product technology become most obvious to the construction crew. As soon as the dilute stabilizer solution is applied to the soils, as has just taken place ahead of the mixing equipment in this photo, the operator of the tractor unit that is pulling the disc, or the operator of the motor grader that is blade mixing the treated soil, will need to shift down to a much lower gear in order to maintain forward momentum. The EMC squared stabilizer develops cohesive forces that work within the treated material and manifest themselves by becoming more resistant in behavior to the progress of the mixing equipment. The operators describe this phenomenon with comments that the stabilized material almost immediately becomes heavier to process. The internal cohesive forces pulling the material together make it much easier to compact and contribute to pavement improvements in density strength and resistance to moisture penetration. Not to limit thinking to the treatment of clay soils only, the application of EMC squared treatment in the previous two photos and this compaction photo are of a road construction project where more than 100 miles of stabilized aggregate surface course were constructed over stabilized native silty sand soils. The range of different types of granular and cohesive soils that can be effectively treated with the EMC squared stabilizer products is unmatched by any other stabilizer product technology. Mixing method number 2 is using rotary mixers, working in combination with surface sprayed applications of the stabilizer solution by water trucks. This process involves multiple application, mixing, and compaction passes, as we are viewing here in the construction of a stabilized soil working platform. Clay soils, by definition, are classified as cohesive soils, as opposed to the granular soil classification. Cohesive soils have high strength when they can be maintained near their optimum moisture content. The EMC squared treatments stabilize expansive clay soils by helping to maintain a stable moisture content, resisting moisture infiltration that would create swelling, and resisting desiccation during dry weather that would create shrinking and cracking. This is the direct and economical route to stabilize soils, by making the treated soil more moisture resistant and less susceptible to fluctuations in moisture content. Mixing method number 3 is using rotary mixing equipment with onboard metering systems, so the application of the EMC squared stabilizer solution and processing it with the soils can be achieved in a single mixing pass, followed by multiple compaction passes. In the project shown here, the material being stabilized is a moderately expansive silty clay soil. The fourth option would be using stationary mixing plants so that the materials treated with the EMC squared stabilizer solution can be trucked to another location and placed by asphalt paving machines. In this case, the project in construction is a running surface that is being paved with an EMC squared stabilized aggregate mixture placed on top of an EMC squared stabilized soil base course. 10 different applications follow where EMC squared products were effectively utilized. In all 10 cases, the EMC squared stabilizer treatments are keeping water out of the treated layer. The graphic illustrations for these different types of applications are illustrated by a horizontal red bar showing the moisture-resistant layer produced by the application of the EMC squared stabilizer product. All these projects have case studies available for review from our website. The first application is the use of EMC squared products to construct stabilized working platforms and stiffened compaction platforms. This project was a 1-year-long mobilization of a concrete batch plant operation atop the expansive clay soil treated with the EMC squared stabilization product we saw earlier. The stabilized soil performed in all weather conditions while in service under heavy truck traffic and the operation of a large front-end wheel loader. EMC squared stabilizer products are formulated to keep water out of treated materials, so it makes sense that they are ideal for constructing working platforms and haul roads accessing construction sites. It is important that good drainage and cross slope be included to all types of applications where stabilized materials will be used for a period of time or permanently without being covered by an asphalt or concrete pavement. Highway projects also require stable working platforms and stiffened compaction platforms. It is a fact that the performance of base course layers is highly influenced by how densely they are compacted during the construction process. It is impossible to achieve high-density compaction unless the soil subgrade beneath the base course provides a rock-solid compaction platform. Huge cost savings can be achieved by using EMC squared stabilizer products when stabilized soils replace the need for aggregate base materials. There are many cases where an EMC squared stabilized soil material can provide a base layer that is as strong as an aggregate base layer of similar thickness and far more resistant to water penetration. Two of these projects are over 100 miles in length, and in each case, project owners save tens of millions of dollars by building their roads using EMC squared stabilized soils in place of conventional crushed aggregate materials. Stabilizing 12 inches of locally available soil for this county road in the middle of the Bakken oil field area in North Dakota eliminated the need for 14 inches of crushed aggregate and reduced the thickness of the asphalt pavement by 2 inches. Pictured here is one segment of over 100 miles of roads in Saskatchewan, Canada. At a fraction of the cost of using cement and fly ash, EMC squared stabilized soils replace the need for importing crushed aggregate materials for base course and surface course applications. EMC squared stabilized soil eliminated the need for importing hundreds of truckloads of crushed aggregate materials for this city expressway in California. Stabilized soil for construction of the access road of a new federal penitentiary in Central California eliminated the requirement for importing hundreds of truckloads of crushed aggregate base materials from a distant supply source. The stabilized clay soil served as all-weather access road through 2 very wet winters before the road was scheduled to be paved. EMC squared stabilized soil eliminated a requirement for importing over 1 million tons of crushed aggregate base course material during the construction of 116 miles of military supply routes used by military tactical equipment such as Abrams battle tanks and the convoys of huge transport trucks that move the battle tanks to the most distant practice ranges at Fort Bliss Army Base. There are many situations where the high cost of asphalt pavement is prohibitive, and other situations where asphalt pavement materials are simply incapable of surviving super heavy loads. In many cases, EMC squared stabilized aggregate materials can provide a more cost-effective alternative as a running surface. This stabilized aggregate running surface for the pipeline haul road in Alaska remained essentially maintenance-free for 3 years under haul truck traffic servicing the Prudhoe Bay oil fields. This stabilized gravel surface of a Forest Service logging road in the Ozark Mountains in Arkansas provided over 20 years of impressive performance from a single application of EMC squared stabilizer. This stabilized aggregate running surface of the Bureau of Land Management road accessing the north rim of the Grand Canyon provided over a decade of effective service. This access road to a power generation plant in New Mexico was surfaced with an EMC squared stabilized aggregate to provide a tractive surface and support the move of extremely heavy transformer equipment up a steep grade. The running surface of military supply routes in New Mexico and Texas was paved with EMC squared stabilized aggregate placed on top of the EMC squared stabilized soil base course. EMC squared stabilizer products also can be used as effective treatment for many asphalt millings and recycled pavement materials, again providing a water-resistant layer, whether as a stabilized base layer or running surface. City streets in New Mexico paved with EMC squared stabilized asphalt millings provided 5 years of maintenance-free service before being swept with a power broom and overlaid with hot mix asphalt pavement. Faced with delays in environmental permitting for an asphalt parking lot with drainage to a protected coastal estuary, a university in Southern California installed an EMC squared stabilized mixture of recycled pavement aggregate running surface that provided 5 years of maintenance-free service before being power broomed and overlaid with hot mix asphalt pavement. SFDR, or stabilized full depth reclamation, is the terminology for milling or pulverizing the full structural section of an existing distressed pavement and recycling those materials on location as a stabilized base course for a new asphalt pavement. The roto trimmer machinery pictured here during full depth reclamation of a segment of interstate freeway in New Mexico has just pulverized 6 inches of asphalt pavement overlays on 8 inches of old concrete pavement in a single pass. What is shown here is a second mixing pass where the EMC squared stabilizer is being metered into the mixing chamber to produce a stabilized base layer that will support a new hot mix asphalt pavement surface course. Full depth reclamation of mountain roads on the Mescalero Apache Reservation in New Mexico. Pictured here is the asphalt pavement that was placed on the EMC squared stabilized base composed of recycled asphalt pavement and base course materials from the old paved road that has been reconstructed. There are many specialized applications where large expanses of native soil materials can be economically stabilized with advanced stabilization technology at far lower cost than any other alternative. A single treatment of EMC squared system stabilizer product can provide long-term closure of a large land area at an installed cost similar to that of a single dust control product application. The bare earth areas surrounding runways and taxiways at El Paso International Airport in Texas are stabilized with EMC squared stabilizer treatments to protect against erosion, dusting, and weed growth. The permanent final closure caps of hazardous waste landfill cells in Southern California were constructed with EMC squared stabilized soil covers. This is an application where cement and lime treatment would be unsuited because they generate shrinkage cracking, while the EMC squared treatments retain the natural elasticity and self-healing properties of clay soils while shedding water and armoring the constructed soil cover against the erosive effects of sheet flow drainage. At a solar power generation site in Northern California, EMC Squared stabilized soil provides all-weather access to a field of solar arrays. The construction site for a big box store in the Phoenix Valley needed to be mothballed for a number of years. A single EMC Squared stabilizer treatment provided years of erosion and dust control at a fraction of the cost of annual polymer sprays or thick aggregate cover blankets. Many projects require protection against wet weather conditions during the late fall, winter, and early spring months. On a dirt road in Mobile Bay area of Alabama, EMC Squared stabilizer treatment solves school bus access problem and provides rock-solid support through 60 inches of rain during a hurricane event before the county placed a hot mix asphalt pavement on the stabilized soil base layer. EMC Squared stabilized base course applied to the subdivision streets for residential development in Northern California provided all-weather access for contractors through winter weather until hot mix asphalt pavement surfacing could be placed. Cold winter weather conditions at the high altitude road accessing a large aggregate mining operation in Nevada precluded placement of hot mix asphalt surfacing for 6 months. The EMC Squared stabilized base course provided a rock-solid running surface for hundreds of aggregate haul trucks each day. Atmospheric river flood events later swept away new asphalt pavement at river crossings while the EMC Squared stabilized base remained untouched. 6 inches of EMC Squared stabilized clay provided all-weather support for Abrams battle tanks on trails at Fort Carson in Colorado that otherwise generated 2-foot deep ruts when driving off the well-drained stabilized dirt running surface. The water-shedding stabilized surface layer works this wonder by keeping the subgrade soils below in dry condition. EMC Squared stabilized clay provided a resilient and erosion-resistant surfacing for a forward landing strip, or FLS, for C-130 landing and takeoff operations of the famous 82nd Army Airborne Division at Fort Bragg, North Carolina. Testing in federally funded pavement materials testing laboratories has documented the fact that EMC Squared stabilized aggregate mixtures can be formulated to construct flexible base layers that are moisture resistant, resilient, and protected against permanent deformation under extremely heavy loading. This behavior makes them an attractive base course layer under asphalt and concrete pavements. Pictured here is the placement of an EMC Squared stabilized base course on top of a previously built highway subgrade treated with EMC Squared system stabilizer products. This reconstructed section of Interstate 40 in New Mexico had its surface life more than tripled as a result of using EMC Squared stabilizer products for construction of both the subgrade and base course layers. In addition to reducing construction costs in comparison to conventional highway design or line treatment, this stabilized structural section reduced the required thickness of the asphalt pavement surface course by 2 inches. An EMC Squared stabilized recycled pavement materials mixture was used for the construction access road to the $800 million Port of Los Angeles expansion project. The stabilized material provided 2 years of maintenance-free service as a running surface before being power broomed and converted into a stabilized base course layer with a hot mix asphalt pavement overlay. As stated earlier, EMC Squared stabilized soil subgrades provide stable working platforms and stiffened compaction platforms. The performance of the base course layer is going to be influenced by how densely it was compacted during the construction process. A rock-solid subgrade soil platform is the best way to achieve high-density compaction of the aggregate base course. Here is subgrade stabilization work in progress for a reconstructed section of an interstate highway that outperformed the service life of the previous pavement that had been constructed according to conventional design, without stabilizing the subgrade or the base course, by a factor of more than 3 times. This area of the President George Bush Turnpike in proximity to Dallas-Fort Worth International Airport is noted for its highly problematic expansive clay soils. The concrete pavement and asphalt base course layers were constructed to top the EMC Squared stabilized subgrades treated as deep as 34 inches below the pavement structural section. Given the strange reality that water flows uphill through capillary action and soil suction, there are many applications where the construction of a stabilized soil moisture barrier would be advisable to protect structures and pavement structural sections from the upward movement of water from groundwater supplies. Here are 2 examples of projects designed with EMC Squared stabilized soil moisture barriers. At an intermodal container transfer facility connected to the Port of Long Beach, located next to the Dominguez Channel and constructed above deposits of high capillarity silty clay soils. Project engineers designed their paving projects constructed next to the water conveyance channel with an EMC Squared stabilized moisture barrier under the pavement structural section. A state highway was built through permanent ponds in the Trinity River watershed in Dallas, Texas. Project engineers specified construction of an EMC Squared stabilized soil moisture barrier at the bottom of the new embankment, just above the surface elevation of the ponds located on both sides, and then specified an EMC Squared stabilized subgrade at the top of the embankment, immediately below the pavement structural section. Cost savings on projects constructed according to engineering designs incorporating EMC Squared system treatments range from 25 to 50%, most often resulting from stabilizing native soils or recycled pavement materials instead of importing manufactured aggregate materials. Strengthened road base and subgrades also reduce pavement thickness requirements and dependence upon costly hot mix asphalt materials. The EMC Squared System Construction Handbook and General Information Booklet contains the data and formulas needed to determine the applicability and quantity of EMC Squared System products. The handbook is downloadable and available upon request. While EMC Squared stabilizer products are indeed cost-effective and easy to use, they are not magic. The broad spectrum of the materials that can be treated and the diverse types of applications may seem too good to be true, but 30 years of laboratory and field tests and even more successful project stories beyond what was shown in this presentation are testimony to the impact of EMC Squared system products. The outstanding projects that we have just toured are the result of high-performance products used in combination with knowledgeable technical support services. Every successful project involves serious planning and rigorous attention to quality control during construction, and we don't imply otherwise. Contact us to discuss your current and future projects. Thank you for your attention in reviewing this presentation.